officially start, I'm going to mention just a couple of words about our program, Invest Horizon Accelerator. This is an accelerator that's promoted and financed by the European Commission. It's a 3-year project that accommodates or plans to accommodate by the end of 2021 in total 500 SMEs that are looking for their Series A funding. We from TechTour are the coordinating partner of this initiative, and together with our 6 other partners, as you can see them listed here on the slide, BPI France, Meta, BWCon, Eura, EBN, and ESE Business School, we are delivering different free services for all of these companies that have applied and were accepted. One of these services is, of course, also this pitching forum that you are seeing today. Before we start, a couple of housekeeping rules. We're going to record this meeting. So please, if you are against to be recorded, indicate this into the chat. Also, we are testing our streaming functionality, so we are going to stream this meeting in YouTube. If you are against that, again, please indicate this into the chat and we'll make sure to cut you off. Please name yourself with name, surname, and company, so we better know who is in the room. You can turn off your microphone for the better quality of the session, and please stay with your turned on camera so we can shorten the distance. Of course, you can use the chat functionality anytime to reach out to me or the team if you have any questions. And later on during the Q&A session, all of the expert juries will be asked to use the chat to write down their questions, and we'll know the order, how to go next. Before we start, we are here for the next hour and a half. This is the short agenda we have. Just in a second, I'm going over to the investors and experts we have in the room this afternoon, and I'm going to give each of them 30 seconds for a short intro. Once we are ready with this, we move forward to the pitching companies. We have 7 presenters this afternoon, and all of them are looking forward to pitch in front of you. And last but not least, we are going also to collect your opinion about these pitches. This is going to be anonymous feedback in our online evaluation form. My colleague is sharing the link inside of the chat for all of the expert juries. You can reach it there. And please indicate the different notes you have for the pitchers. We are going to share this feedback so they can improve for next time. Without any hesitation, I move forward to the introduction part. And I would like to give then the word in alphabetical order to our expert and juries that are here inside of the room. And I would like to start with Michele. Hi, Michele. Good afternoon once again.
How are you? Yes, this is Michele Appendino, AME Ventures in Milan. We are controlling shareholders of Solar Ventures, which is a renewable energy, solar energy IPP. We've been investing in the sector for almost 15 years. And so we cover both the technology side and also the infrastructure side. We are active in Europe. In the past, we were also active in Middle East and Asia. And today we have a big pipeline of market parity projects, mainly in Southern Europe.
Thank you, Michele. I go over to Grégoire. Hi, Grégoire.
Hi, my name is Grégoire. I'm a mentor at InnoSwiss, which is the Swiss Innovation Agency, and I'm also director at ProKilowatt, which is a funding program of the Swiss Federal Office of Energy for electricity efficiency.
Thank you so much. I move forward to Saleh from UVC Partners. I hope I pronounced it correct.
Caleb, yeah, no problem.
Caleb.
So, no problem. UVC Partners, we're based in Munich and Berlin. We're a typical seed and Series A stage venture capital firm, backing B2B tech startups, both on the hardware and software side.
Thank you so much. I give the word now to Daniel from InnoSwiss Business Angel.
Yeah, nice to meet you, everyone. I'm InnoSwiss coach. I'm also a business angel of the boss, and having also invested directly in some startups. So a bit on across the board.
Thank you so much, Daniel. I go over to Hans. Hi, Hans.
Hi, Denitsa. Nice to be here, to be part of this jury members today. My name is Hans Kool. I work for Eneco Ventures. Eneco is one of the biggest utilities in the Netherlands. We serve over 4 million customers. And we have a ventures arm that invests into scale-ups active in the energy transition fields, typically in Series A, companies that are active in our main markets, the Netherlands, UK, Germany, and Belgium. So very interested to see interesting ventures that are presenting here today. Thank you.
Thank you, Hans. I give the word now to Philip from vVenture. Hi, Philip.
Hello, everybody. Hi, Denitsa. Good having us. We are a VC from Germany. We are invested in 24 companies and an amazing startups and people, and that's what we are looking for today. Our focus is into energy, mobility, and food. Our sweet spot is for our first ticket about 500,000, and we are very interested in seed and Series A rounds, and lucky to be here. Thank you.
Thanks, Philip. I give the word now to Kaiser from ETF Partners.
Thank you, Denitsa. Yes, we're very excited to be a part of the jury today. ETF stands for the Environmental Technology Fund, and we are a London-based venture capital. We're investing in exciting sustainability companies across Europe. We usually come in at a Series A and Series B level, and we're excited to see the companies today.
Thank you so much. I give over to Ekaterina from Sabic Ventures. Ekaterina, can you hear us? I will move then to the next one. Maybe if you can introduce yourself just in a second. Andre, good afternoon.
Yep, good afternoon. Thank you, Denitsa. Andre Lejeune, I'm a former founder and CEO of a software business that was acting globally, and now I'm actually investor and executive advisor in a couple of scale-ups across Europe in software, but also in green energy and automation systems. So I'm very, very curious and happy to be here and curious to see the presentation this afternoon. Thank you all.
Thank you so much. I go over to Brian from Aster Capital.
Hi, everyone. Thank you, Denitsa. Yes, so Brian, I work at Aster. We're a Paris-based VC firm with offices in San Francisco, London, and Tel Aviv, looking at seed and Series A opportunities across energy, mobility, and Industry 4.0. So looking forward to hearing from everyone today.
Thank you so much. I would like to give the word now to Christine from Diamedcare.
Yes, hello. My name is Christine Miller. With Diamedcare, we hail from the life science field, but have expanded tremendously over the last 2 years. What we do is we provide working capital for hardware as a service companies. So every company that has a piece of equipment or hardware who wants to basically commercialize via subscription models or recurring revenues, we are basically the balance sheet, taking care of the hardware, so you can avoid raising additional equity for that. Thank you.
Thank you, Christine. I give the word now to Isabel from Rosa Blanche. Would you like to go for a short intro, Isabel?
Yeah, so I'm Isabel Schirmer. I'm based in Switzerland. I've worked extensively in industry and energy, including for BP PLC. I manage a VC fund dedicated to clean tech, and now I invest through my own family office company, which is called Rosa Blanche Ventures. I'm primarily interested in mobility and energy transition.
Thank you so much, Isabel. I go over to Hans-Georg from White & Case.
Yes, hello. I'm Hans-Georg Scholzer, a local partner at White & Case, which is an international law firm, and we're advising here on mainly in the energy sector, at least the Berlin team where I'm based here also, and advising corporate VCs and PEs in energy transactions, but also sometimes in mobility sector, just like 2 weeks ago when we advised SoftBank on their Series C investment in Tier.
Thank you so much. I would like to give the word now to Christian Schutte. Hi, Christian. Good afternoon.
Hi, good afternoon, everyone. My name is Christian Schutte. I have a background of more than 20 years in the VC industry. I established and run and invested a 150 million euros fund as a managing partner. And now I'm working on my own. That means I'm investing my own money as well as I'm consulting, advising young startups. I'm focused on B2B, most likely patent backed. Thanks.
Thank you. I give the word now to Jim from Vardis Capital.
Vanessa, thank you very much. I'm Jim Totti. I've been working in the energy technology sector since the 1990s, worked on first renewable energy deals on that decade, and then as an investor in private equity for the last 20 years, primarily in energy across renewable energy, technology and infrastructure, and also energy efficiency.
Thank you, Jim. I go over to Richard. Hi, Richard. Good afternoon.
Yes, good afternoon to everyone. Good evening. My name is Richard. My background is, not surprisingly, in the energy sector, some part in renewable and the rest in oil and gas. Also take parts in some corporate investment. It's a pleasure to be here this afternoon, and I'm looking forward to some exciting pitches. Thank you.
Thank you. Thank you, Richard. I give the word to Marcel. Hi, Marcel. Good afternoon. Thank you for joining also today.
Yes, good afternoon. Welcome, everybody. Well, I'm Marcel van Berkel. I work for the Biobased Delta. It's a foundation for the development of an ecosystem for the bioeconomy. It's our target to reduce, well, about 30 million tons of CO2, and we are searching for alternative and sustainable energy forms.
Thank you. Thank you so much. I gave over to Peter. Hi, Peter. Good afternoon.
Hi, good afternoon. So I'm Peter. I'm an investment manager with Solvay Ventures. That's the venture capital arm of the Solvay Group, so a global chemicals and materials company. We invest in startups that have a link with the strategic business interests of the group. And that's basically it. Thank you.
Thank you, Peter. I give the word now to Thomas from Demeter.
Yes, good morning, everyone. So I'm Thomas Droll. I work at Demeter, a French investment firm dedicated to energy transition and environment sectors. We have 1 billion euro management, and we invest from seed stage to growth equity until project finance. I personally work on the seed fund dedicated to smart city, and we invest an average ticket of 1 million euro. Yes, we are based in Paris, and we have offices in Spain and Germany.
Thank you, Thomas. I give the word now to Carolina from ICOS Capital. Carolina.
Good evening, everyone. Nice to see you. I'm Carolina. I'm associate at ICOS Capital. We are a Dutch venture capital fund. We invest in clean tech, food tech, agri-tech, chemicals, and industry 4.0 across Europe and in Israel. And I'm really looking forward to this session. Thank you.
Thank you, Carolina. I will try again with Ekaterina. I can see that she is here with us. Hi, Ekaterina from Sabic Ventures. Would you like to introduce yourself? Your microphone is on mute, so.
Hi, thank you for introduction. And it's a pleasure to be here within this group. I'm representing Sabic Ventures. We are corporate venture group of Sabic, and we invest into companies in line with our corporate strategy. So we focus on circular economy, energy efficiency, CO2 reduction, and carbon footprint. And it's, yeah, I'm looking forward to talk to these companies.
Thank you. Thank you so much. Then we are done with the round of introductions, and I can move forward to the next step. We officially enter the pitching time. I am happy to introduce to you the 7 companies for this afternoon. And the very first one of them that is going to present is the company Transport and Sebastian. I'm stopping to share my screen, and I'm inviting Sebastian to the floor.
Yeah, thank you.
Thank you very much. Good afternoon, everyone. Thank you for your time. I'll share my screen and then we can start. Can everybody see it? I guess yes. So. Yeah. Yes, okay. Good. So my name is Sébastien Gendron. I am the CEO and co-founder of Transpod, which is a Canadian European company, I would say, developing what we know today as a Hyperloop. So our vision is clearly to be able to provide a better connection system and develop the next generation of ultra-high-speed transportation system, of course being sustainable, 100% electric, and being able to contribute to reduce greenhouse gas emissions by removing some of the airplanes between major cities and major corridors. The company has been founded in 2015. We're based in Canada, in Toronto. We have operations in France and Italy. And the system itself consists of developing a vehicle the size of a train coach or a bus, traveling in a tube where you have removed most of the air. And thanks to this concept, you can achieve speed similar to an aircraft, mainly because you've been able to avoid aerodynamic friction. In terms of work, so since 2015, we've raised some money from the Angel Group. It's an industrial company south of Italy. And we've been doing some business development, both in Europe, in Canada as well. We've signed an agreement with the government of one province in the West. And we have also a proposal in the Middle East and also in the US. Regarding the key point and our competitive advantage, it's really beyond the IP, the intellectual property, which allows us to have a lower cost per kilometer for the infrastructure than our competitors. And the IP is public and has been assessed by our current investors and new ones as a key change compared to the other players in the field. And thanks to that, we've been able to secure the initial funding from the Angel Group and also some significant funding from the European Union. Here, some view on how the system works. The main, as a private company, when we decided to start the company with Ryan, we wanted to make sure that future infrastructure could actually be profitable. And in order to do that, rather than looking at the occupancy of the vehicle, we are looking at the occupancy of the infrastructure. And in order to do that again, mainly because we have a vehicle which is smaller than a train, you can mix it with freight transport. And so we're adding actually up to 3 additional revenue streams to an infrastructure project. So the first one is passengers, second one, freight, third one, as you can see on the slide, is from energy, from solar panels, and the fourth one is fiscal. And if you're interested, we can talk about that later in the Q&A session. The team, quite diverse. We're lucky to be in Toronto. For those who don't know, the city is really, I would say for me, an example in terms of how many communities kind of coexist in a good way, lots of tolerance. And naturally, when we recruit people, they come from all over the world. So we have people from Iran, Russia, China, Sweden, France, anyway. And the beauty of it is that we've been able to reproduce that model in France and soon in Italy. Get to the next one. For application use, so passenger and freight as discussed, and we can also do airport connection. So of course we won't go 1,000 kilometers an hour, but we can have the same model as the line in Shanghai for those who have experienced that connection. Passenger experience, the main point behind it is really to be able to remove the stress from traveling. Today, when you want to board an aircraft or a plane, you always have the stress to be stuck in traffic and to miss it. And so that system will provide the frequency of the subway with the speed of the aircraft. So even if you're not exact on time at the stations, you can board the next vehicle. We're talking about the vehicle every 2 minutes. We're working as well on different customer experience to really have a better travel, I would say, experience in the future, and many ideas, and those are kind of initial design we'll unveil next year. Few words on investors and partners. So we talk about the Angel Group, European Union. We got some funding from the region, from Nouvelle-Aquitaine in France. We're working with EDF, Mars, SAD, which is a subsidiary of Veolia, and so on. Last word or slides to finish. This is our timeline with the project in Alberta. We're currently discussing with financial institutions to secure the financing of a first phase. We aim for certification between 2025 and 2027, and having that line to connect Calgary and Edmonton to be operational, I would say, between 2030 and 2035, and negotiations are currently happening between those players. That's it for me. Hopefully I'm not too much behind schedule, and open to any questions people may have.
Thank you so much, Sebastien, for this presentation. I'm opening the floor now, or the chat, for the questions of the experts in the room. Please, if you have a question, type it down in the chat so we know the order of those. I can see that Carolina has the first question. Carolina?
Thank you very much for your presentation, Sebastian. So I wondered specifically what part of your solution is patent protected?
It's patented, so the power transmission and the propulsion, the levitation, and how the system is controlled. This is key to lock down, I would say, the tech. If you don't have that, you must, I would say, use existing technologies such as maglev. And the challenge with maglev is that it's just 5 times more expensive than what we do. And we've been testing all that in lab as of today. It's working pretty good. And we'll unveil actually a technology demonstrator by spring next year to actually explain in details. As an ecosystem, I think that the Hyperloop community didn't do a good work, and I include ourselves, to actually go into the details and convince people how that system can work at 1,000 kilometers an hour. So now our IP has been published, patented, tested in lab, and then the next step is to actually unveil it to the public and have a meaningful conversation to those who are not convinced yet.
Okay, understood. Thank you.
You're welcome.
Thank you so much. There are some more questions, and the next one is from Jim. Jim, would you like to unmute yourself and ask the question directly?
I'll start again. Thanks, Sebastian, very much for your talk. I think you just said you're not using magnetic levitation. So could you just talk us through what your propulsion system is?
So we are using magnetic propulsion and levitation system. What we're not using is a maglev type system, the way we know it from Japan or China. Just in few words, the maglev system in China and Japan are using the principle of repulsion, like 2 magnets repulsing each other. So you need to have a magnet on the track and a magnet on the vehicle. What we're using is actually the other functions of a magnetic system is traction. So the levitation system is actually at the top of the vehicle. So all the technology is concentrated on the vehicle to avoid having magnets on the track, which is the expensive part. And we levitate thanks to the metallic tube and the electromagnet on the vehicle. So we actually control the electromagnetic field between those electromagnets and the tube in order to maintain a consistent gap between the vehicle and the tube. And this is what we will reveal within the next 3-4 months as of today.
Okay, thank you.
Yeah, and happy to go more in details on that. It's just amazing.
Many thanks for the questions and for the answers as well. We are out of time for you, Sebastien, and you're going to receive all of the questions from the chat in a private email directly to you. You're welcome to follow up these questions during the one-to-one meetings in the chat functionality here in this meeting or on our Tech Tour platform as well.
Yeah, of course, yeah. I see some good ones, TRL, revenue, and so on. It's good.
Wonderful. Thank you. I would like to invite now on stage Reinaud from Skypool. So whenever you're ready.
Great. Good afternoon, everyone, and good morning for those in the United States, if there are any from there. Let me see that I am actually having the correct screen here. Are you seeing the presentation, Denitsa?
We're seeing the presentation, but not in screen mode, like not
now.
in full screen.
There.
Now it's
there
perfect.
Okay, yeah. Great. So my name is Reinaud Ossoor, and I'm the CEO of Skypool, and Skypool is producing energy utilizing drones and altitude winds. We are clearly trying to see that we are going to provide a sustainable impact to the transition from the current market of fossil fuels to renewables. There's obviously a lot of technologies that we are competing with in the renewable space, but we are looking specifically at bringing more availability of renewables, efficiency, and obviously scalability at a cost that is manageable and comparable to that of today's fossil fuels, being coal or natural generation gas in the United States. So how do we go about that? Well, the traditional wind turbines, they are operating at typical hub heights of about 100 meters elevation above ground. Skypool will operate at 200 to 600 meters elevation above ground. If you can see on the map on the right-hand side, it opens up in the coloration in yellow, orange, and red, a substantial larger area for deployment of airborne wind systems such as Skypool. The solution, we are having a patented boxed wing design drone that is specifically designed for energy capture. So the wing profiles have been specifically designed and patented in order to pull tremendous lift in our system while reducing drag, not only from the flying vehicle, but also from the tether that is an ultralight cable with which it is connected to a ground station that consists of a drum where the tether is unwinded while the wind is pulling the actual drone away from the ground station during the traction phase. That again drives a generator in the ground station and pushes the electricity in the grid. So the actual energy generation is happening on the ground and not at the drone level. The drone is the pure driving force of the actual ground station. So what does this do to a customer from a customer's point of view? Well, first of all, because of the fact that we are operating at 200 to 600 meters, we are having substantially stronger winds and more dense winds and also more constant winds compared to the lower elevations. That leads to our systems of a comparable size of a traditional wind turbine to produce double the energy compared to traditional wind. It also has a substantial elimination of about 90% of the weight of a traditional wind turbine system. So as such, a substantial easier transportation to sites that are in remote locations, as well as a much lower CO2 footprint during manufacture of the components. As such, we are targeting a $30 per megawatt hour of cost of energy, which is comparable to that of fossil fuels. The market opportunities, initially we're targeting with the small 100 kilowatt systems, the typical applications where today diesel generation is predominantly found. That can be in science and defense, can be in agriculture, can also be in disaster relief. Mining is a large opportunity in areas like Australia and Africa, where a lot of those systems are operating on diesel genset as well. We're targeting only a very small portion of that market opportunity, approximately less than 1 promille of the overall deployment over the next 10 years of new systems. Thereafter, we're going to the megawatt scale systems that are clearly targeted towards augmenting existing wind farms by co-locating airborne wind systems with traditional wind turbines in order to increase the capacity factor of those systems. At first, the channel partners will be used, such as Caterpillar and Cummins, typical diesel genset suppliers. Thereafter, we are going with the larger megawatt systems directly to the wind farm developers or the utilities such as Enel or E.ON. We've got a team that is consisting of entrepreneurs and specialists that bring 25 years of experience with GE, as well as most recently with Northern Power Systems, a major North American manufacturer of traditional wind turbines. Our investment proposal asks for about 3 million in total. Currently 400,000 has been subscribed and secured by our current pre-seed round investor. And most of these funds will be used for ongoing engineering and system development of the SP300, our 25 kilowatt product available to the market by the end of next year. Our financials lead to profitability in 2023 with the introduction of the SP600, 100 kilowatt platform, thereafter growing into substantial millions of dollars of revenue and EBITDA results. Intellectual property is secured for 2 patents are granted with another 2 currently pending. Acknowledgements from Hay 2020 in the phase 2, where we have been consistently over the last 6 months meeting the seal of excellence from the European Union. And last but not least, we are having various statements amongst others from the leading traditional wind turbine manufacturers, being one of the few companies that are considered based on their technology and their product design for a major impact into the wind business moving forward. Thank you.
Thank you so much for the presentation. Now is the time that we hear the questions from the audience, the experts and the investors in the room. Until we're waiting for the first question in the chat, but okay, it's already there. Marcel was the first one.
Yeah, I was wondering, what is your go-to-market strategy? Are you partnering with one of the windmill producers, or are you doing it 100% yourself? Or
that's a very interesting question, obviously, Marcel. It is kind of crystal ball at this point. Obviously, initially the market introduction from the SP600 will be done by ourselves through strategic partners that will be primarily the channel partners in the diesel genset supplier industry. Those people have a vast distribution network in place that is leading to all of the final applications, whether it's mining or whether it's remote islands, where the initial systems will definitely be installed. So it is first channel partners, thereafter it is potentially strategic partners in the form of large wind turbine manufacturers, or a slower start and doing it ourselves.
And will you, what is your business model? Will you produce the units yourself, or will you license?
We will take care of the critical components, so the software, the controls, the inherent intellectual property in the drone. Certain parts of the drone will be manufactured in-house, but ultimately an industrialization will happen where we are relying on partners to produce the large components and then do the assembly eventually ourselves.
Thank you.
Thank you so much. We are ahead of time, and we can give the word to Ekaterina for a question, and I'm afraid it will not be enough time for the next one.
Yeah, hi. Thank you for this presentation. At SABIC, we looked at similar technology as a kite wind turbine, but using drone, I think it's even more interesting. We within our company, we have such a program like a local content. So we look at these technologies, what we can bring to Saudi Arabia. And I think definitely we have to get in contact after this meeting. Do you have a pilot, or like my question was like, do you have pilot or demonstration, or how do you prove what it really works?
Yes, very, very good. We have obviously completed our proof of concept that was at the end of 2019. We have completed by June 2020 a technical demonstrator that is currently operated on our test site. We have a test site at Montbar in Switzerland where we are continuously operating and doing test flights. So we do have a working product that is actually able to be operated whenever the wind blows.
Okay.
Thank you. Thank you so much. We're out of time and there are a couple of more questions in the chat. We're going to provide those in a follow-up email to you, Renaud. And also I'm going to follow up with everybody after this session, providing the emails of the companies. So whoever wants to follow up via email can do that directly as well. Wonderful.
Great, thank you.
Thank you so much. I'm moving forward to Paulo from Zafiro Technologies. So Paulo.
Yep. Do you hear me?
Yes, we can hear you very clearly and you can start sharing the screen.
Trying it. Do you see it?
For me, still no picture. Oh, and here it is. Yeah.
Okay.
Wonderful.
Good. Hello, everyone. My name is Paulo. I am the CEO and one of the co-founders of Zafiro Technologies. Zafiro is an innovative company in the domain of smart grids. We're based in Lausanne, Switzerland, and we develop SynchroGuard, a solution that helps utilities, power utilities, to integrate more renewables, but at the same time, improve the resilience of power grids. Power grids are indeed the most critical infrastructure of our modern society. They power our homes, they guarantee uninterrupted supply to our hospital during this pandemic, but are meant to play an even more central role in the transition to a clean energy future. Nevertheless, to be able to integrate such an amount of distributed generation, EVs, and etc., there is still a lot to do. Indeed, even today, the best performing utilities worldwide, such as Enel or E.ON, are still suffering of three main problems. First of all, their grids are poorly monitored and automated, and this is endangering the reliability of their grids. Second, blackouts still cost billions to the society, as most of these utilities still rely on the end clients to report a blackout and on field crews to manually search for the fault and clear it. And last but not least, the integration of renewables and electric vehicles is putting additional stress on the grid, which is increasing the risk of blackouts. At Zafiro, we have developed a novel solution to tackle each one of these problems. Our solution enables, first of all, full grid visibility with 200 times more data generated than conventional solutions. It helps reducing the duration of blackouts from hours to seconds, and it helps utilities in the widespread adoption of renewables and EVs via automated battery control. Our innovative solution is called SynchroGuard. It is covered by key patents, and it consists of a combination of our proprietary hardware on the left-hand side and our software platform on the right-hand side, which together expand the capabilities of today's utility control systems. Our hardware is able to provide measurements of voltages and currents with unprecedented speed and time synchronization in order to be able to detect and locate the even fastest events such as faults or the intermittent behavior of renewables. On the right-hand side, our software is processing all this data in real time, and it is separated in different modules. Real-time monitoring to provide full grid visibility with 200 times more data generated than conventional solution. Outage management to reduce the duration of blackouts from hours to seconds, or even to prevent them. The first control solution for utility scale batteries to always guarantee the stability of the grid. And last but not least, an advanced analytic platform to perform, to implement optimal grid planning and predictive maintenance. Compared to conventional solutions that distribution system operators, which are our client, use nowadays, SynchroGuard represents, first of all, a single source of truth for them, as it combines into a single software platform, monitoring, control, and blackout management functionality. Second, it provides full grid visibility with 200 times more data generated, but using 3 times less devices than conventional solutions. Third, it helps utilities to integrate 300% more renewables and EVs in a safe way without any grid reinforcement, which is expensive. Fourth, it helps them reducing the duration and the impact of blackouts thanks to our automated fault location solution. And finally, it is the simplest to install in power grid as it doesn't require the shutdown of any substation. Our solution outperforms existing one provided by the market leader, which are the big players you see in the slide, but also startups in this field in terms of both scalability and performance. Our main competitive advantages refers to our unique measurement technology and our scalable software platform that can easily adapt to the needs of our clients. The business model is, try to move ahead. The business model is separated in 3 main revenue streams: hardware with an upfront fee, software, a yearly software license, and services. The services represent, the software part represents around 70% of the total project value when rolling out a solution in larger scale. Today, we are rolling out mainly pilot projects to test our solution in representative portions of their grid, but we have recently signed a first full grid rollout with a client in Switzerland. Until today, Zafiro has accumulated more than 2 million euros revenues with margin in the order of 45% and clients from Switzerland, but also working with one of the biggest utilities in Asia Pacific, which is China Light and Power Hong Kong. And we have also some new opportunities that we're about to close with the utilities in Europe and Middle East. Our team counts 8 FTEs with our management team composed by the 3 co-founders, plus the support of Francois Marty, a former C-level manager of big corporate, who is leading today our business development activities. To conclude, this is Zafiro in a nutshell, but I would also like to remind you that we are currently fundraising. We are looking for 4 million euros Series A round to scale up our business, and we'll be very happy to get in touch with interested investors. Thanks a lot.
Thank you so much for the presentation. I can see that we have from Isabel Schirmer our first question. Isabel, would you like to unmute yourself and ask the question?
Yes. Yeah, so I'm interested to understand how does your solution or your product compare with Depsys. I saw Depsys for competitors. It's also a company located near Lausanne, and you know, on the surface, it looks like Depsys is offering something quite similar, and I believe might be slightly ahead of you commercially.
Yeah, they are. I wouldn't say they're definitely at a later stage of us. They developed a technology which is similar in the sense it's both a combination of hardware and software, but their target is another type of application and use cases, referring mainly to the low voltage grid, which is one of the various segments of the power grid. We focus on the medium and higher voltage levels. And the main, as I said, differentiating factor with several companies, including Depsys, is the type of measurements that we use, which is unique in this field.
Okay, thank you.
Thank you so much. Then we're waiting for the next question to appear into the chat box, and it is coming from Carolina.
Thank you for your presentation, Paolo. What kind of data do you gather and analyze a part of the sensor data?
The data that we analyze are, I wouldn't call them sensor data, are already pre-processed sensor data that we collect in the field with our devices. We refer to, as I said in the pitch, voltages and currents measurements, so electrical measurements, which allows to provide visibilities in the first stage of the grid, and then additional applications as fault management or control of various grid resources. But to answer your question, we're talking about grid data, so electrical grid data.
Okay, thank you.
You're welcome.
Thank you so much. The next question is coming from Hans Kohl. Hans?
Yes, nice presentation, Paolo. Thank you very much. I'm just wondering, could you give us a little bit more insight into the sort of commercial traction that you are seeing right now?
Yeah, so in our industry, it's pretty usual that with clients, you go through an entry phase, which is a pilot project meant to test and parameterize the solution in a representative portion of their grid, so pilot grid, and then moving to a large-scale rollout. Until now, we have been rolling out pilot project, but as I mentioned in the pitch, we have been signing in July the first full grid rollout with a company here in Switzerland, a grid operator here in Switzerland. It's therefore the first big achievement of Zafiro, I would say. And in parallel, this year we started the commercialization of our product in Europe, but also outside of Europe, and we have been leveraging some partners. Today, we are about to close a contract with the first utility in the US, and also, as I mentioned in the deck, We are very close to close some deals also in Middle East, which is, let's say, our second client in that region.
Thank you, Paolo, for answering the question. We are apparently out of time, so the next question we'll leave in the chat and we're gonna provide it back to you. So you can follow up directly here or later on when you receive the email from us. Thank you so much.
Thank you.
I would like to invite to the stage then Sandra from SEAP Power. Sandra.
Hello, everybody. Yes, I'm here. Thank you. Let me get my screen so I can share it. Go. Okay. Hopefully you can see that in full screen.
Yes, indeed. The floor is yours.
Okay, perfect. My name is Sandra Sasso, and I'm the co-founder and CEO of SEAP Power, and we're headquartered in the United Kingdom. So we all know that there's a tremendous issue with bio-waste, such as food waste in the world, and that it's responsible for a large portion of the greenhouse gases, around 8%. We have a client, Portugal's largest supermarket chain, who came to us with a problem. When we met them, their food waste was being segregated from the packaging, but while their packaging was being recycled, their food waste was still being sent in a truck to landfill. So we set out to find a solution and to help them generate some energy from it. So we sold Continent, one of our FlexiBuster units. It's a decentralized solution for recycling organic waste using anaerobic digestion. So now they don't have any collection vehicles coming to the site. They've eliminated their issue with odor, and they're generating renewable electricity right at the store level. They even plan to bottle and sell the fertilizer in the store as another source of their revenue. So with FlexiBuster, Continent turned their waste into a value and their savings of around 85,000 euros a year. And Sanai is not alone in Europe or even around the world. There are plenty of municipalities and companies that are looking to do just what they did, reduce their costs and go green. So we've sold units into France, the UK, Italy, Portugal, and the US, and we have a specific target of vertical markets that we're focused on. They're installed in buildings and next to buildings, and they include the likes of a French waste management company, Sepur, and Google's New York City headquarters. So our value proposition to them includes carbon reduction, water reuse, and a significant savings on waste management and renewable energy. Their return on investment averages around 3.5 years, and they help us to sell to new customers by acting as our reference sites in their vertical markets. So the FlexiBuster was designed and developed in-house by SEAB, and we remain the design authority. But as we move to commercialization, the production and assembly have been outsourced to partners in the UK and Lithuania and the US, which keeps our need for working capital low. Our sales partners include large energy and utility companies such as Enagás, Veolia, Engie, and then some more localized companies. And for installation, commissioning, and maintenance, we've outsourced to NOV, which is an $8 billion global provider of equipment into the oil and gas sector. And they're offering this service as part of their strategic move into the renewable energy sector. We sell the product currently, but we're also looking at a service model using some project financing. So now we're continuing to build on our successful sales with a focus on municipal waste and waste management companies in our addressable market. And once we've reached our targets, the FlexiBuster has a potential to reduce to treat 6.3% of Europe's waste and obviously waste in the United States, and reduce Europe's methane emissions by 14.5% and the CO2 emissions by 1.5%, which is not negligible. So we're in a good position for 2021. We've got contracts and letters of intent in hand that cover the sales needed to meet our targets. In addition, we have a strong inbound sales demand that's bolstered by our partner relationships with these global waste management companies. And we've got a 22 million euro pipeline. The opportunity value keeps going up and our sales cycle keeps getting shorter. So most of our companies that we worked with hired consultants to search for suitable solutions for their waste and for their renewable energy needs. In the case of Google, they reviewed 45 other different things they could do with their waste before choosing FlexiBuster. They graded us on FlexiBuster's unique architecture, the energy recovery efficiency, the automated process, the patent protection, and the pricing. And Google even factored in the diversity of our team, which was interesting for me. But what won the deal for us was the fact that FlexiBuster could be integrated into a building. And the reason it can be integrated is because we've embedded safety and proprietary odor control. So we've been very efficient in our use of capital, keeping our core team to 3 people, the co-founders and Graham Allen, who's our head of engineering. Governance is provided by our chairman, Alan, who was head of Arab's global waste practice. And we have board observers from Enagas, our corporate venture funder. Kerry, who's also on our board, comes from the scale-up ecosystem in the UK. And then when we need extra bandwidth, we go out into the market and work with consultants in operations and commissioning, research development, sales strategy, and then we work obviously with the partnerships that we've established. So where are we? Well, we've sold 7 units. We've agreed the next 8. We've raised 2 million in corporate venture and angel funding. And we went through a full round of due diligence with KPMG to do that. We've also raised 20 million in project finance to deploy our systems on service contracts. And in order to take advantage of the massive US market, we recently opened a US subsidiary. So now we're raising our Series A+ round with our current investor contributing to the round. Plan to grow our revenues on a mix of new CapEx and service sales supported by software license fees, which double the revenue of the sale over the 20-year projected life of the product. We'll also have a positive EBITDA in 2021. And based on recent market exits in the waste sector at 14.5 times earnings, we're projecting an IRR of 50% on this investment round based on a conservative multiple of 11 times earnings. We plan to use the funds to build our team to get UL certification for the US market, to build more demonstrator units, and to kickstart our US subsidiary. So now's the right time to invest with us. We hope we'll do that. Waste is a problem. So is the need for renewable energy, even in a pandemic. And so now with all the legislation moving in our favor, we have the solution for waste management in our future cities. Thank you.
Thank you, Sandra. Thank you for the presentation. I give the word very fast to Hans because we are over time.
Yeah, Sandra, very interesting presentation. Congratulations. I'm just wondering, how did you get here so fast? So you set up the company in 2017. You're a small team. You seem to have developed this technology or made this product at least. How did you do that in such a short time?
So anybody that looks at us in detail will find that we fell flat on our face with the first go round. And so we picked ourselves back up. We acquired the technology out of the old entity and raised for more funding. The co-founders funded the original entity that did all of most of the development work. And so the new company ended up having to finish the delivery of the first sites and raise the round of capital, which we secured. But the original development was done over an 8-year process. So we've picked up, I wish it would be that quick. We were still very efficient, but we weren't quite as efficient as that.
Okay, all right, thanks.
Thank you so much. I give over to Jim.
Where's Jim?
Yeah. What average availability are you achieving on your 7 units installed?
Sure. So uptime is around 95%.
Okay, this was a short answer and straight to the point. Wonderful. I give over back to Hans with the next question.
Can you tell a little bit about how sensitive it is, the process to the feed that it's taking in, and how homogeneous does the feed need to be?
Yeah, sure. So we spend a lot of time. We spent quite a bit of time testing our units on a variety of different sites. And the verticals that we've concentrated on are the ones where we've managed to make it work. So we've developed a front module called the mouth, which is, we have it in a supermarket, a catering waste, and a sewage waste version. And that's all we do. So we're very specific on the types of sites that we'll install in. And the first sites that we have are in all of those verticals.
Okay, understood. Thanks.
Mm-hmm. Thank you so much. The next question from Carolina.
So what is the price per unit and what are your revenues up to date can be for 2020?
Sure. So the price per unit is average is around 300,000 euros. And we have we do half yearly. So we just went into a new year. So we've done 300,000 so far this year, and we're on target to do 1.6 million. But overall, in the technology itself, we've sold 3 million between this company and the old company of tech.
Okay, thank you.
Mm-hmm. Thank you. And the last question is coming from Isabel Schirmer. Isabel?
Yes, so yeah, I was interested. I agree with the previous comment that you've been going extraordinarily fast, but now we understand why.
Yeah.
But I wanted to understand, what is your exit strategy?
Sure. So we're currently working obviously with Enagas, who's a corporate venture investor with us, and with NOV, who is a production partner of ours and also offering the maintenance. We're anticipating, there's been an expression, I guess, of interest from NOV to do an acquisition over time. They're obviously doing a very strategic move out of oil and gas into renewables, and that will take time. So it's not an immediate, but they're offering now the maintenance for us. They're building the front end module for us. And so slowly they're getting a feeling of comfort in terms of the market size for our product set.
Mm-hmm. But they're also a shareholder, if I understand.
Not yet. No, NOV is not yet a shareholder. Enagas is.
Okay. Thank you. Mm-hmm.
NOV is an $8 billion US oil and gas service company.
Mm-hmm. Okay. Now I understood they had invested through a VC arm, but
no, not yet.
Okay. Thank you.
Thank you. Thank you so much for all the questions and all the answers given. I would like to move forward as we are out of time. Thank you, Sandra.
Yeah, it is anaerobic digestion. I did for the last question.
You can follow up on the other questions after that or in the chat also directly. Thank you. I give now the word to EcoWave Power and Matthias. So Matthias.
Hello, thank you. Okay. So the world needs to move away from fossil fuels, not only to combat climate change, but to supply affordable energy. I'm Matthias Sigal from EcoWave Power, and I will tell you about an overlooked source of green energy, wave energy. EcoWave Power developed an innovative technology to harvest the power from the ocean and sea waves. We have our unique approach installing the system onshore. And because of this, our capital expenses are up to 9 times lower than other wave energy technologies. We have a great momentum operating 2 wave power stations and with more than 250 megawatts in project pipeline. And last year we made IPO in Nasdaq First North. Also, we have a strong intellectual property portfolio. So as we know, we are living in an unsustainable present with most of the energy coming from fossil fuels. And this is the cause of climate change. Wave energy can be part of the solution because most of the world is living close to the coastline and we can produce electricity close to the big cities. Wave energy is stable, being able to produce electricity around the clock, and it's abundant. The World Energy Council estimates that wave energy can produce up to twice the amount of electricity that the world produces now. So why it failed until now? And the answer is that most of the companies install their systems in the offshore, around 5 kilometers out from the coastline, depending on divers, boats, and underwater cabling. And also they were exposed to a tough environment of waves that can reach 20 meters and destroy those systems. When we develop our technology, we tackle all these issues by deploying in the onshore. We attach floaters, as you can see in the picture, into existing structures like piers, jetties, and breakwaters. The floaters moves up and down with the motion of the waves, making a piston compressed hydraulic fluid, which goes into an accumulator, creating pressure that turns an hydraulic motor and turns a generator, which provides electricity to the grid with an inverter. We reach to be reliable because we have a storm protection mechanism, as you can see here in the video. When a storm is arriving, the floaters lift from the water level and protect from that storm. So it's also fully insurable, it's cost efficient, and 100% environmentally friendly because we don't create any new presence in the ocean. We use the existing infrastructures. Our business model is 3 different options: is to build, own, and operate the stations and have revenue of the selling of electricity. We can also build, own, operate it, and then transfer the station, or work under turnkey and joint venture projects. Until now, the company was founded in 2011, and in 2014, we built our first station in Jaffa Port in Israel. Right now, this station is being expanded in a cooperation with the EDF, the French National Electric Company. Also, this station got recognition by the Energy Ministry of Israel as a pioneer in technology. Then we have our station in Gibraltar, which is the only wave power station in the world connected to the grid under a PPA, a power purchase agreement. And we have more than 250 megawatts in project pipeline, which means that we can power up to 250,000 homes. Last year, we did IPO in Nasdaq First North in Stockholm, so we are ready to build our next commercial projects. Here, I'm opening to you an opportunity to make a step for a more sustainable future. We are looking for strategic partners in the energy field and to discuss with investors to help us build our next projects. Thank you.
Thank you so much, Matthias, for this extremely to-the-point pitch. 1 minute earlier even, you were ready. So we are opening now the chat for the questions from the audience, the jury members, the investors and experts. Until we're waiting for the first question, if you didn't manage to mention something, please do so. As soon as we have the first question, I will directly give the word to the jury members.
Sure, no, I mentioned everything, but also I will be happy to follow up or have an individual meeting if needed, so I can leave my email here.
I'm going to provide all of the emails of the presenting companies to everybody from the expert jury members as well as among yourself in the follow-up email. So
perfect.
Okay, I can see that they are pretty silent, but I actually have my own question. You are talking, okay, Ekaterina is the one to post the question, Ekaterina?
Yeah, here I can see the question, what's the biggest challenge to commercialize the type of technology? So yeah, the biggest challenge is actually because it's not a commercial technology, there is not established framework, legal framework and permit path. So in most of the countries, there is not established path and we have to create it, but we tackle it by doing strategic partnership with local companies, for example, with EDF, as I explained, or by discussing with relevant consultants that help us to go through that path. But I can say that's the biggest challenge.
Mm-hmm. So do you have patents on your technology?
Yeah, we have 17 patents and patent pending, and also a PCT, that protects the technology in different countries of the world.
Mm-hmm. And is it a mechanical solution?
Yeah, also, like we have the mechanical part that harvests the power from the waves, and then the hydraulic system that converts into electricity.
And you compress the air, I guess.
It's actually a fluid that we compress.
Okay. Yeah, because I've seen that kind of technologies coming to my site for, I don't know, last 10 years, but we never seen such a development like with wind powers, and I just wonder why.
Yeah, it was a question, sorry, or can you repeat?
Why, yeah.
So,
yeah, I see there are some more questions, so I won't take time. But I think the biggest challenge is the plenty of mechanical parts, and I think many investors just kind of scared of this.
Yeah. Also, most of the companies went to the offshore, as I mentioned a little bit. So, it's really different, the system and the capital that they need to install the systems, and also most of them were destroyed after raising some millions. And that's a big difference. And also we have the experience of how it connected to the grid since 2016.
Okay.
Thank you. Thank you so much. The next question comes from Jim.
Thank you very much for a great talk. You talked about a Nasdaq IPO, but how much capital are you looking to raise going forwards?
Yeah, so, well, we did the IPO last year. So we are now trading in Nasdaq First North, that is in Stockholm. So right now we're a public company. However, we will be also always happy to discuss about investment privately.
Okay.
Thank you. Thank you so much. And there is time for one last question. I can see that Daniel is having it.
So yeah, it is. So Daniel, do you want?
Oh, you already read it, but basically it's to be installed on infrastructure that are existing. So how much is limiting? Because otherwise you cannot put it any way you like.
Yeah, you're right. So we target existing infrastructures. As you said, there are less infrastructure than the thousands of kilometers of coastline. However, there are a lot of ports and marinas and infrastructures owned by governments around the world. So there are thousands of them. So at the moment, we don't find there's a limitation. But it helps us to target better our audience and our projects at the moment. So there are thousands of them available, for example, in port authorities. And so we are working with them right now.
But you have special requirements in terms of depth of the sea or whatever it is. Is it limiting or not?
Yes. So we are looking for infrastructures that are, first of all, open to the ocean. So we need that the infrastructure is open to the waves, and also the material of the infrastructure is relevant to see that it will be easier to install the system. And of course, we need a minimum of depth in the outside part to install the floaters. So.
Okay, I think this was clear. Daniel, is it fine? Do you have a follow-up question, or it is enough as an answer?
Oh, enough for me.
Thank you. Thank you so much. Thank you, Matthias, for the presentation once again. And now is the time to give the floor to our next presenter. And this would be Paulina from HelioRec. Hi, Paulina.
Good afternoon. You can hear me well?
Yes, we can hear you very clearly.
All right.
Yes, wonderful. The floor is yours.
All right. Good afternoon, everyone. My name is Vasilienko Paulina. I'm founder and CEO at HelioRec. We are a clean tech French-based startup. We are building innovative floating systems with a circular economy approach. These floating systems helps reduce construction cost of solar power plants, increase efficiency of solar panels, save land space, and unlock new market opportunities. We want to solve 3 problems. Land preparation is difficult to expensive. Low efficiency. The solar panels are overheating on the ground. High carbon footprint during manufacturing and transportation. Our solution solves these problems. Installation of water, no need to prepare land. High efficiency due to cooling effect from the water. Maximum low carbon footprint with circular economy approach. How floating solar looks like. The solar panel installed on our patented floating system, this hydrolock feature. The solar panel produces electricity, and this electricity flows through electrical cable, and mooring line secures the power plant on the desired location. Our current status. In September this year, during a pandemic time, we installed the pilot project for 7 kilowatt in Russia. It is autonomous, unique hybrid system. So we connected floating PV and aeration system for lake purification. Our main competitive advantages are unique design. Why it is unique? Because we have a hydrolock feature inside the floater, and it gives stability. We patented this idea. We have passive cooling system, and it helps to increase efficiency, and the floaters are very compactness, and we can save the transportation cost by 50%. The second advantage is a circular economy approach. It helps reduce carbon footprint 5 times lower than competitors, and low raw material cost by 30%. And additionally, we can provide services with machine learning algorithms for system optimization. In Europe and Asia, we have some competitors, but we are better than them in some parameters like efficiency, cost, flexibility, using circular economy, and machine learning. Nowadays, floating solar markets are booming market. Nowadays, installed 2.6 gigawatt, and by 2025, market size will be 10 billion euro. Our business model is quite simple. We subcontracting for now plastic manufacturers. They build our floating system. We sell it to our customers. It can be utility companies, hydropower station owners, or it can be the port owners. So we sell our system with margin 20–30%. And additionally, we sell the services like engineering, operation maintenance, and machine learning. We receive the payment from the customer. A customer can use own photovoltaic equipment, or we can give it. Together, we construct floating solar power plant, and we generate clean electricity for end users. Value proposition for customers is no need to prepare land. It's the most eco-friendly approach. So for every installed 1 megawatt the power plant, we can save 128 tons CO2 due to circular economy approach. We can reduce capex by 17% and LCOE by 20%. Our roadmap you can see details a little bit later maybe. In 2023, our revenue will be 11 million, and we will launch offshore projects. Now we are looking for 1.3 million euro for key hiring, extra IP and equipment, and we will buy equipment. So up to date, we raised it to 200,000. We patented our system, registered trademark, and we have memorandum of understanding on 80 megawatt. We are a team of international enthusiasts. I have 2 master degrees, chemical technology and renewable energy, experience 18 years in energy sector, and I'm winner of Women in Green Tech. Andrea is CTO, PhD, aerostructural design from Imperial College, London. We have Irena, Director of Operation, PhD in Financial and Sustainability. Also, we have David and Grigori, engineers. Thank you very much for your attention. Hopefully it was interesting for you.
Thank you, Paulina, for the presentation. The first question is already there in the chat from Isabel. I'll invite her to unmute herself.
Hello, yeah, thank you for your presentation, very interesting. I'm interested to understand what is currently your LCOE across the pilots or the prototypes you have, and what are the key drivers of the LCOE given the type of technology you're using?
So our core technology is the floating system. So we develop is to make it stable and the most cost-effective system. So in comparison with our competitors, for example, retail companies, so cost of our system 3 times lower than their cost. And for us, like key drivers, you mean to build our system or key drivers for the customer? Drivers, you mean?
What key drivers for the customers, but I'm looking for a number, for what, what's your euro cents per kilowatt?
Okay, so yes, it was on the
just
slides.
To give I didn't say.
Yes, usually now we are telling our customers, so let's install it on the water. So for capex, compared with typical land-based installation, it is around 750 euro per kilowatt installed, and our system will cost 630 euro per kilowatt. And LCOE we calculated for France, so it was reduced by around 20%. So LCOE is 72 euro megawatt hour for land base, and for our floating system it is 59 euro per megawatt hour.
Okay, thank you.
Thank you so much. The next question is from Caleb.
Hi, great presentation. I'm just wondering, a lot of ground mount systems are moving towards tracking and bifacial over the next 5 years, probably. So is it possible to use that with your system?
Yes, we developed azimuth tracking system, so we can move it by like azimuth way. We have this, so it will be not possible right now without technology to move it like axial tracking system. But it's in the progress. So for now, we developed azimuth, but did not install anything yet, because we are actually we started our journey in 2019 in the beginning. So we're like 1.5 year old startup. So, and we installed the pilot project right now, just without tracking yet.
Okay, thank you. I can see that Caleb is fine with the answer. I will go over to Kaisa from ETF.
Yes, thank you, Polina. That was a very interesting presentation. I just want to know, what's your current traction in the market? You said you had one pilot already installed. Do you have any other ones coming up? And when do you see you can become commercialized?
Yes, so next year we want to, let's say, the pre-commercialized stage. Due to pandemic, some testing was postponed. Our plan is to test our system in Wave Tank in École Centrale Nantes next year in April. So original plan it was this May, but no. We have 3 projects and pipelines next year. So one is in frame of dual ports program. It's European project in Belgium, Ostende port. We will install the pilot in the sea. Second, it will be a hydropower station in Russia. So we are Russian-French base startup. So hydropower station in Dagestan region in Russia. And the second one, we started to talk with EDF Hydro in France, also for hydropower station.
Okay, thank you.
Thank you.
Thank you. Thank you so much, Polina, for answering all of the questions. There are a couple of those more in the chat, but we are out of time. So we are going to provide those to you, and you can also read them, of course, also directly in the chat. Thank you.
Thank you.
Our last but not least presenter for the evening is Stefan from Zapgo. So I would like to invite him to the floor, and we're eager to see his presentation as well.
Hello, everybody. My name's Stephen Voller. I'm based in Oxford in the UK, and we make supercapacitors. What I'd like to do is something different, not share any PowerPoint with you, but to show you some technology this afternoon, if that's okay. So supercapacitors normally look like this, and they're fantastic things that will enable most of the technologies that have been talked about this afternoon for renewable energy. But if you were to use one of these in a mobile phone, what would happen is that you could charge your phone in seconds, but it would only give you a couple of minutes of use before it ran out of energy. And what we're looking to do is to keep that property of charging it in seconds, but to change the materials inside here so that they can hold on to the energy, which means that we can get to a mobile phone that can charge in seconds, but will last all day. Now, the other aspect of this, of course, is that if you're trying to put it in one of these, it isn't a very good idea. So one of the things that we've done in our technology is change the shape so they can go inside phones and things like that. But actually, this is a longer term project. And really where we're aiming with this for the consumer electronics markets are the next generations of phones, which will be foldable, which can fold out. So we're not looking to retrofit them to existing phones, but for new phones that will come out over the next 3 or 4 years. So the screens can fold out to be much larger and be the size of a tablet. And if you're going to do that, one of the things that you do need to do is to change the design, because The glass, the thing on the front of this, is the bit that shatters, but it's there because it gives the phone rigidity. And if you didn't have that, what would happen is that the phone would just flop about. So another way of doing it is to make a rigid battery. And this is one of our products embedded in a very tough carbon fiber material, which can provide the backbone of that material. Now, where this also becomes interesting is in electric vehicles, because today what happens is that those vehicles are packed with lithium batteries, which provide a huge amount of expense. Also, they're difficult to control because you need to cool them. So instead, what we can do is make this type of material any size or shape, so it can form the actual body structure of the vehicle. And that means the vehicles are much cheaper to make. It also means that they're much safer because our cells don't catch fire. And it means that they can be deployed in new generations of vehicles, which are designed to be autonomous, for example. Now, one of the things that we've been doing is we've been developing an autonomous vehicle where we designed the charging characteristics so that the vehicle charges in just 35 seconds. And that's done by having a combination of our cells and conventional lithium-ion cells that are on the vehicle. We can also deploy it in other products like power tools. This is a power tool that you'll recognize from a well-known brand. And right now, there's no energy in it at all. And I'm just going to plug it in to a conventional plug. And what you can probably see on the front there is the voltmeter where it's charging up. So this drill will actually charge in about 10 seconds. And then it's ready to go. And once it's ready to go, it will give you what's called constant torque. So you know that thing, if you've ever tried to use one of these, when the battery flattens a bit, you try and put a hole in something and it just won't go. And you end up doing this with it to try and screw it in. Well, this will give you that full power in an instant into the battery. It would do if I had it on right. But that's one of the technologies that we've been developing here in Oxford. So what we're also about is supporting many of the applications that were talked about today, particularly with grid energy storage. And one of our first deployments is looking to deploy cells like this that would go in large containers and provide the grid energy storage that would support renewable energy as well. So we have a number of different aspects. Our go-to-market strategy is one of licensing. So we don't have a manufacturing capability here, but we have a manufacturing partner in a large, well-known battery company who would do that. So what we do is that we go and talk to the manufacturers of these, and we license our technology so that they can go and manufacture the cells. So we're looking to put together a round now of about 5 million euros to get us to a point where we can deploy these technologies, build up the team a bit, and go to market. Thank you very much.
Thank you much. Thank you so much, Stephen. I'm thrilled to listening to you, and I can see that the first question is already in the chat from Jim.
Thanks very much for your talk, Stephen. I guess key interest with a capacitor is how you do make the duration for discharge much longer than would be normal with a capacitor. How do you do that?
Well, the IP originally came from the material science group at Oxford University. And what we do is we replace the conventional carbons that are used in here with higher surface area carbons and the normal electrolytes, the organic electrolytes with an ionic electrolyte. And what that does is it allows us to improve the voltage of the cells. So the cells which are in here are operating at 4 volts, whereas these tend to operate around 2.7 volts, which doesn't sound a lot of difference, but the energy you store is proportional to the voltage squared. So it's like an exponential relationship in terms of proving the energy density. And when we can get to 5 or 6 volts, which we intend to do over the next few years, then we can start to reach the energy densities of lithium batteries, which is when it would make it very competitive.
I guess, I mean, with capacitors, you know, we're talking timescales of seconds usually, and you're describing markets that need timescales of many hours. So I've just, you know, that's a couple of orders of magnitude difference.
Yes, it is. And so the cells that we currently make, we can store the energy inside them, provide a usable voltage after 15 days, which is adequate for the first applications that we're looking for. And when we're deploying on the grid, what we'd be looking to do all of the time is to have hybrid solutions where we'd use our cells in combination with conventional batteries. And that means that the supercapacitors can do the heavy lifting of the fast charging and the fast discharge, but the batteries can hold on to the energy for an extended period of time.
Okay, all right, thank you.
Thank you. Thank you so much. I give the word to Marcel.
Thank you for this very interesting presentation, which is without PowerPoint very entertaining, I must say. But my question is about your charge-discharge number of cycles. At which number are you now, and what number are you intend to reach?
So our current generation of cells is 100,000 charge-discharge cycles. And we expect the next generation to be 1 million. A conventional battery is usually around 1,000 to 10,000 to give you an idea of how that compares. So if one of our current cells was in your mobile phone and you charged it every day, it would last 30 years.
Okay.
Thank you. Thank you so much. Thank you also for all the questions. I can see you were pretty clear, Stephen. Thank you so much for the presentation. We're going to share, of course, a recording of the chat with you as well.
Thank you.
And now we are moving forward to the end of our session. I would like to thank once again to all of the 7 presenters this afternoon, and of course to all of the jury members that joined us for the session. Thank you so much. We are going to share a link in our chat where we are asking for your feedback about the session, and you are going to help us, of course, with your feedback to improve. Also, I would like to remind you that this evening and tomorrow the whole day, you have the opportunity to schedule one-to-one meetings and to meet online some of the people that you already maybe know. Thank you so much, everybody, and wish you a lovely afternoon. Thank you.
Thank you.
Thank you. Bye.
Thank you.
Thanks. Bye.
Thanks very much.